In this example, we have been asked to rewrite it as a single logarithm and then simplify if possible. For these type of problems, it's very important that we know our three rules, but specifically that we know our three rules in reverse. The quotient rule that we need to remember is that when you have two logs that are being subtracted, then you take the quotient of the arguments and you write it as a single log. The product rule, the way we need to remember this, is when you have two separate logs that are being added, then you combine them as one single log and then you multiply the two arguments. And then finally, the power rule needs to be remembered as if you have a value that's multiplied in front of a log, then that value that's multiplied in front can become the power on the argument. In these problems, your grouping symbols help you know what to do first. So we see on this one we have brackets. Go and do what's inside your brackets first and leave everything else the way it is. So here we'd have natural log of 2x, leave it as it is, plus a 3, leave your bracket. And then here, notice we have two logs that have the understood same base, and then we're subtracting the two logs. This means we would use quotient rule, we would rewrite it as a single log, and then you're taking the quotient of your arguments, x over y. From here, we still have the bracket. Notice that there's a 3 multiplied in front of this log that's in brackets. That 3 can be rewritten as the exponent on that argument. So leave the first one alone as natural log 2x. And then here, I'm going to drop the bracket, and then I'm going to apply the power on the x over y. From this point, I now see that I have a sum of two logs. Because I have the sum of two logs, then they're going to simplify together, and you're going to take the product of the two arguments. Okay, and then from this point, you've simplified the log into a single log, but you need to simplify algebraically the inside of it. The 2x you could write over 1, and then the x over y to the third, that third power can apply to both the x and the y. I'm actually going to do that first. So it'd be 2x over 1 and then x to the third over y to the third. Okay, from here it makes it easier for me to simplify it. On the top I can multiply straight across. This would become 2x to the fourth, and then on the bottom just a y to the third. And that is simplified as much as possible. You have one single log, which is what the instructions indicated to do, and then on the inside you have a fraction that cannot be simplified any further.